Well, okay. I don't want to say anything. Okay, 13. 13 basically is compute the volume. Compute the volume of, well, it's below to this surface, que es 3x, of y plus c equal 12. It's below this, less than. And c greater than or equal to 0, bounded by the region between x squared plus y squared equal to x. So this is our solid, no? T, defined by that. Okay, so identification one by one. What is the surface that bounded our solid? For example, the first one. What the hell is that? What is the first one? What is the first one? What kind of surface? What kind? Answer me. Answer me. What's going on? Student. A ver, Marco, Fiddy, Carlos, David, and Gerardo. Okay. Come on. No idea. Nobody. Wow. It's a plane. Very well. Gerardo. Always Gerardo answer me. So the only student can know this is Gerardo, no? Plane. How do you know que it's a plane, Gerardo? What is the clue that give you the information que es plane? Gerardo. Degree 1, exactly. And when you see something like that, and the exponent is 1, it's a flat. It's a flat. Of course, 3-dimensional flat is a plane. And what about well, this is actually the region, no? This is above the xy plane. Above xy plane. And what about the last one? X squared plus y squared equal to x. We are talking about surface. Okay? Maybe you have some idea, like a curve on the one specific plane, pero no, in 3D, so the sketch of this in 3D is, come on, what kind? What kind of surface it is? Omar, are you there? Omar Borja, answer me. Yes, no. I am sleeping, or no? Yes, okay. Marco Morales, cylinder. How do you know the cylinder, Gerardo? How do you know the cylinder? How do you know the cylinder? Because there are one specific reason que you understand. He said que cylinder. Degree 2 and degree 1 and another one. No, this is not exactly the conclusion. Okay, because degree 1, degree 2, maybe it's a hyperboloid or something, no? Cylinder. What is the clue to give me information to the cylinder? One verb is missing. Okay, and the verb is missing is Z. Therefore, a cylinder alone, CX. Okay? So let's try to do the sketch in 3D, no? Roughly, sketch in 3D. The plane is easy because the plane we can find, look, let me copy here, 3x plus 4y plus z equal 12. For example, you suppose that x is 0 and y is 0. I try to find intercept on the axis. C is 12. Then we have the first intercept. Okay, here I suppose that distance is 12. This point is the point 0, 0, 12. Likewise, si you suppose que x is 0 and y no, z is 0. Okay, entonces basically I found the y-axis. Entonces 4y equal 12 es obvio que es 3. Entonces es 1, 2, 3. I suppose que here 3. 0, 3, 0. And likewise, si you suppose que y es 0 and z is 0, o sea, y is 0 and z is 0, the equation that we have is 3x equal 12, que x is 4. And the point here, a little bit here, is 4, 0, 0. If you're connecting this point, well, you can see not exactly the plane. You have a portion of this plane lie in the first octave. But the plane is more. The plane is extending totally here in that direction. Okay, but in order to doesn't confuse this, I do the sketch only of this. Okay, I did that. Okay. Everyone understand the plane? One efficiency way to do the sketch of any plane is using intersect on the x. Entonces we have 3 points defined perfectly a plane. C-axis. What happened with the C-axis? Gerardo, you say C-axis. Okay, I understand now. Okay, super. Let's move on to another surface. One is above the XY plane and the cylinder. Let me manipulate a little bit. Cylinder. Cylinder is x squared plus y squared equal to x. Therefore, I manipulate in this way. Minus 2x plus something plus y squared equals something. So you complete the square. And the complete square is 1. And the factorization of this trinomial is x minus 1 squared plus y squared equal 1. And this in 2D represent a circle. In 2D, circle with the center is located at the point 1, 0 here. And the radius 1. So basically, it's a circle like that. Wow, no good, like that. This is in 2D. However, in 3D, no, it's circle, it's cylinder. So we have this famous point. Look. Is 1, 0. I suppose que here 1, 0. We have a circle, but actually this is a cylinder. I don't know. In both directions. Well, no, in the negative direction, no. Important because the boundary up the lower bound is C0. Entonces now our solid is formed by, you don't see very well. I don't see very well. It's a cylinder. However, the cylinder intersected with the plane here at one specific point. Entonces, basically, the roof of the solid is the plane, and the lateral wall is the cylinder, something like that. This is my solid. I have roughly idea No 100%. But you don't need to have 100%. Well, if you want to have 100%, you put in algebra and you try to manipulate algebra. This is my solid. The goal is find the volume of this solid. Volume of this solid. Well, so to find the volume, in this case, I'm using, I don't know, triple integral or double integral. What do you think? Double integral or triple integral? Come on, answer me. Double integral or triple integral? Okay, double or triple? Double. Gerardo dice double. Another opinion. Another opinion. Everyone is agree with Gerardo. Gerardo is a double integral, professor. Okay. Okay. And triple allow me compute the volume also or no? Eh? Come on, answer me. Yes, no. You can also use a triple. Under, yes. Under what condition, Victoria? Under what condition? How you supposed to compute the volume using triple integral? What is the supposition? Victoria, answer me. Omar. What is what? Okay. My question was, si you apply triple integral to compute the volume, what is the supposition que you are doing? Oh, the supposition. My question is, what is the supposition? So I need to make a decision. Double integral or triple integral? Double or triple? Double or triple? Double or triple? Entonces dice, Victoria dice, doesn't matter. Does it matter? Is 3D. Entonces, what is the answer, Victoria? Double or triple? Or both? In the triple, Daniel say, the integrand function is 1. So this is equivalent. Look, this is equivalent. This is equivalent to this. The integrand function is 1. This and this is the same. This is a surprise. You see before in your life that we can use a double or triple under the supposition that the integrand function is 1. Oh, makes sense, Victoria. But I expect that you answer me this. Okay? Okay. Well. Entonces, what do you recommend me? Sorry. What do you recommend me? Recommend me double or triple? Or both? To practice a little bit. Double or triple? Both. Okay, Victoria. Entonces, look. In the double, the integrand function is not 1. It's the C value of the roof. Okay, in this case, the roof is, okay, my C go from 0 to the C value of the plane. C of plane. C of plane. And C of plane, I go to the equation of the plane, que is this. 3x plus 4y plus c equal to, I just isolate the z. C is equal to L minus 3x minus 4y. I type in this. 12 minus 3x minus 4y. Okay, this is my function, que es C value. Now, dA. Okay, dA, you know, is dx dy. Or polar. I don't know if we use in polar. Okay, so this is the region R. And who is the region R? Well, the region R is this. This is the region R. Guys, this is easy. Si you pay attention and you using your brain, you understand very well this. It's no big deal. It's no science fiction. It's logical. However, if you set out the problem using the triple integral, well, I have no idea what system we use. Is cylindrical or Cartesian? Suppose Cartesian, dx, dy, dz. For example, you integrate first dx, dz, and you integrate, bueno, dx, dy, or dA in general. Remember, dA is the combination dx and dy. And the limit of the integration is obvious, que es from 0, que es this point, to the C of the plane, que es 12 minus 3x minus 4y. So when you perform the first level of the integral, que es this, integral dc is z, evaluating between this and this, you get exactly the same of this. And the rest, que es the double integral, you are doing over the region R. Do you see it's the same stupid thing? Yes or no? Answer me, please. We are doing 3 lectures, doing the review. I suppose that this elementary thing you need to understand. Okay. My next question is, in order to solve the double integral, let's do it using double integral or triple integral, but in triple integral, we finish in double integral. What kind of coordinate we using? We using the polar or we using the Cartesian XY? Here, we focus in this picture, in the region R, double integral. What kind of the coordinate you propose me using? You propose me, polar. Gerardo dice polar, professor, polar. And the reason is polar because you are dealing with the circle. Circle is super fantastic, polar. Ok, entonces polar. Entonces en polar. Okay, let me set up. Okay, well, in polar, I need to transform a little bit. The double integral. Because I need to write, for example, 12 minus, entonces x is no x, is the formulas. X is equal r cosine theta, and y is equal r sine theta, ¿no? Entonces es 12, entonces instead of x you put 3 times r cosine theta minus, ¿no? 4r sine theta. Okay, this is my new integrand function after the transformation with the polar. You replace x and y by r cosine and r sine. I forgot here, r. And the Jacobian is r dr d theta. Okay? Yeah, I suppose that the first integral is dr. So the limit that I put here and here is r limit. So I come back to my region. My region go. Look at the r. The r in any point is from this to this. Okay, this distance is r. Well, actually, it's not constant. It's variable. Look at that. Different r. Entonces r go from 0, que es the origin, to something, to 1r, que es the r of this equation. So I need to transform it. I think the sketch is wrong. The sketch is wrong. No, it's not wrong. The center is 1,0. Yeah, you are right. The center is 1,0. Okay, let's do it in the sketch big. The center is 1,0. And this point is 2,0. Because the radius is 1. Excellent, Gerardo. You always help me. And thus the radius go from 0, que es the origin, to the any point on the region. This is my region. Look. This is my region. Entonces es, wait. Entonces, how you find this R, que es a variable? How you find this equation for this R? Bueno, es, you take the equation of the cylinder. I transform it in polar. I know que x squared plus y squared is R squared. Ex is 2R cosine. And you eliminate the simplification, a little bit 1R divided by R both sides. R is equal to cosine theta. Okay, super. Entonces, this limit is no constant. This limit is variable. This complicates a little bit the manipulation of the integral. Because when the limit is constant, we can separate in two integrals. But in this case, no. You use iterate integral. So integrate the first level, integrate the second level. And now, finally, theta go. Be careful. Theta go from 0. ¿Qué es this? Theta is 0 here. And travel in this direction. In this direction, unfortunately, guys, it's not to pi. It's just pi. It's pi. Okay, I don't know if you remember very well or no. Polar coordinate. But if you are doing the graph and polar coordinate of this circle, look, let me show you, for example, suppose the equation in polar is R to cosine theta. Suppose theta equals 0 degree, or radian, sorry. Cosine is, cosine 0 is 1, is 2, so it implies R is 2. This is this point. However, in theta equal pi over 2, 90 degree, cosine 90 degree is 0, so R is 0. So this point is exactly the origin. Therefore, when you travel from 0 to pi over 2, actually the thing we are doing is in this direction. Using the idea of the symmetry, I suppose, using my imagination, que the other direction is another pi over 2. So totally, when you go theta equal pi, you start for the starting point, the initial point. But just in case, let me verification, theta equal pi, cosine pi is negative 1, ¿no? Entonces negative R is equal negative 2. Wow, what the hell is that? Well, okay. How you plot the point? How you plot the point? Negative 2 comma pi in polar. Well, remember in polar plot, you are doing the angle first. Angle first pi is 180 degree in that direction. But the radius negative 2 is opposite direction. Entonces you start in this point. Everyone follow me? Everyone follow me? Everyone follow me? Everyone follow me? Okay, everyone understand? Okay, 100. Everyone understand very well how I set out this double integral to compute the volume? Okay, now the complication of the calculus 2 now. Yes. Carlos Duque dice yes. Yes or yep? Yep. Okay. Entonces now, bueno, hay multiplication, everything by R. So the double integral that we need to do is, okay, integral from 0 to 2 cosine theta. Entonces we have 12R minus 3R squared cosine theta, because you multiply by this R, the Jacobian part, minus 4R squared again, sine theta, dr. So we focus in the first part of the integral. So I like that way. I don't know if you like or not. I taking that part, I ignore temporary, of course, take the theta and the second integral, because this is iterated integral. You are doing step by step. You focus your attention in R, and after you focus your attention in theta. Okay, entonces en R, bueno, I suppose que es easy, because the antiderivative of this is R squared divided by 2, entonces 6R squared. Do you follow me? Antiderivative of this. Antiderivative, this is r cubed divided by 3, entonces es minus r cubed. And cosine theta stay la que consta. Minus 4/3 r cubed sine theta. This is the antiderivative, and you evaluate in between 0 and 2 cosine theta. Okay, entonces es basically let me see. Okay, you replace 2 cosine theta for r, and you replace 0 for r. Es obvio que 0 es 0, pero cosine no. Cosine is complicated because when you square this guy at 4, la 2 square at 4, cosine square theta, multiplication by 6 is 24, no? 24 cosine square theta minus, let me see the second is cubic, entonces 8 cosine, cosine. Entonces, how many cosine we have? Well, we have cosine theta cubic and multiplication by another extra cosine is cosine 4 power theta minus, well, 4/3. I copy that, but this is 2 cubic is 8. This is 8. We have cosine cubic, theta, and sine. This sine stay here. Look. Okay, so basically the answer for the first piece of the integral is 24 cosine squared theta minus 8 cosine 4 power theta minus 32 over 3 cosine cubic theta sine theta. Okay, super. I think no, because I need to perform the most complicated part, and the most complicated part is the integration with respect to theta, que unfortunately it's not constant. Well, the limit is a constant. The limit is I need to perform the last part is the integral from 0 to pi of the 24 cosine squared theta minus 8 cosine 4 power theta minus 32 over 3 cosine cubic theta sine theta d theta. Wow, hard, eh? A little bit hard. And this moment you make a decision, do it by hand, or you put in Wolfram alpha. What do you think? Opinion. Wolfram alpha or by hand? Wolfram alpha or by hand? Eh? Annette here. Wow, Annette, are you late? Wolfram alpha. Victoria said Wolfram alpha. Wow. Okay. No. It's up to you. Let me know. We are doing by hand or we're using Wolfram alpha. Victoria, a ver, Wolfram alpha. Okay. But in the test, no. In the test, you need to show me the word. Fortunately, I don't put this example in the test. No, Gerardo. David Restrepo, what do you think? Opinion, guy. Wolfram alpha, you want to see by hand, Crazy, or Carlos Duque? Fiddy, Marco, Morales. Anne, what do you think? Anne, are you there? Answer me. Yes, no, I am sleeping. Annette, no. Annette sign in and go back to the bed to continue sleeping, no? Annette, not here. Okay, no attendance. Okay, Annette. Entonces, now, what is the conclusion? By hand or Wolfram alpha? Come on, guy. I need to make a decision. Wolfram alpha. Ok, entonces Leonardo dice, no. Dice, no, this is too much. Well, it's not too much, but it's okay. I agree with you. Entonces Wolfram alpha. And Wolfram alpha I put, and the answer is 9 pi. End the story. Final answer. Any question? That was 13 problem. Okay, let's move on to the 14. 14 is easy or relatively easy. Do you see can always is possible separate the double integral or the triple integral in 3 or 2 integrals separately? No. Entonces, you only can do that when the limit is a constant and the function, the integral function, is separable. In this case, no. In this case, it's iterated integral. Okay, entonces 14 is the last one. I suppose that you take advantage of this fantastic review. In my opinion, it's fantastic. I don't know, see, compute this double integral. Some people send me the test number 3, the answer for the test number 3. Some people. I don't check it, of course. I check in Tuesday because I wait until Monday gets the last due date. No? And the region is bounded by the region R. This region R is bounded by this case x squared plus y squared equal to x. It's exactly the same example, no, that we are doing, and the line y equals x. It's obvious that that problem is 2-dimensional, not 3-dimensional. So the interpretation, this region R is flat. It's a plane. It's a plane, no 3D. Okay, do you understand, right? XY. We are doing now only one sketch in 2D, no sketch in 3D. No. Okay, now because the part in 3D is giving us y. Y is a surface, C equal y is a plane. Okay, this plane is located perpendicular to the whiteboard plane. Perpendicular, no, es okay, es in the z-axis, pero es in the other plane. But I don't care because I consider it like a double integral. The integral function is y, and the region is defined by this, que es the thing I want to do now. No? So this I did before. So this curve is a circle, no? It's a circle where the center is in 1,0. And the radius 1. I don't want to repeat again this because it's the same. It's a coincidence in the example. And the other is a line. The famous line can be set first quadrant and the third quadrant, but I don't care because the third quadrant don't participate in the game. This is y equals x. The basic the problem say, let me see, bounded by this. Well, it's not clear. I suppose it's this region. See, no more specification. We can suppose this region, or we can suppose this region. ¿no? Pero bueno, okay, I suppose this region. Suppose que the professor don't explain more things, entonces now I assume that this is our region. I need to find maybe this point. Well, it's easy. This is easy geometry. You can see this point is 1,1, no? And this point is 0,0. Easy. Okay, so now I need to make important decision. I using polar or I using Cartesian? What do you think? Polar or Cartesian? Polar or Cartesian? Polar or Cartesian? Let's do them both by curiosity. And you see the advantage and disadvantage of the both method, no? Suppose that I'm doing using Cartesian first. The Cartesian is, for example, U integration is double integral. I put the integral function get y. I make a decision, integration first with respect to y and x in this order. In this case, it doesn't matter what order. Pero, okay. You know, see no specification. I like personally, I told you, in this order. So this is dy first. So when the spherical, it's dy first. And y go from this value, y equals something, and y equals something. And this something is the line, the equation for the line is y equals x. Entonces, this is x. This is x. And another is the x of the, you know, the circle, no? The y, sorry, of the circle. Entonces, the y of the circle, let me copy my equation for the circle, que is x squared plus y squared equal to x, no? Entonces, you isolate the y because it's this y. Okay, try to find. So y squared is equal to x minus x squared. Apply square root both sides because I need y alone, no y squared. Y alone is equal plus or minus square root 2x minus x squared. And of course, I take the positive part because the positive part is that part. It's a square root 2x minus x squared because the negative part for this point is this. Okay, no, I don't. Well, see, I need to find in this region, yes, maybe. So I go from the square root 2x minus x squared. This is the integration in this direction. And when you finish this direction, you extending in this direction and this direction. Okay, from 0 to 1. Done. This is the setup for the double integral. Any question? You don't see? It's confusing. I don't understand anything. I never understand calculus 3. Answer me, or you understand? Oui, clear. Okay, guy, do you see? I try to do my best. Because I expect that you are doing your best. Of course, your best is relative. Yeah, great. When this story ending, I assign 1 grade for you. But you try. So you see the professor doing your best to explain clear, to bring any tools, explanation, in my opinion, no, it's relative, no? The truth is relative in the life. You believe that you explain good, but no, you explain very bad. I don't understand anything. Okay, to say now, okay, sorry. You need to retake again this class. Okay, so let's do it by hand or Wolfram Alpha. What do you think? By hand or Wolfram Alpha? In this moment, I make a decision. I need the professor say, okay, I need to. Okay, by hand or Wolfram Alpha? Come on, opinion. Come on, guy, participation. A ver, Jocelyn, Jocelyn, you are there. Jocelyn, are you there? Answer me, Jocelyn Hernández Nieto. Okay. Do you understand, Jocelyn? Yes or no? Yes. Annette, no. Annette is sleeping, no? Definitely. And Annette is sleeping. Okay. Leonardo, everything okay? Leonardo? No answer. It's also sleeping, Leonardo. You are a good student. All good so far. Okay. Wow. By hand. Gerardo dice, I propose by hand, professor. Okay, let's do it. Entonces, by hand, Leonardo, Gerardo, we focus en this integral. Entonces, es integral antiderivative y with respect dy es y squared over 2. Evaluate in between x and square root 2x minus x squared. This is not equal. This is the supposition que I split in this part. Entonces u squared, entonces es obvio que es 1/2. I put outside. And you square that part, que es 2x minus x squared minus x squared. A ver, let me see. Yeah, x squared. Entonces, actually is 2x minus 2x squared divided by 2, ¿no? Divided by 2, let's cancel the 2. The answer so far is, wow, it's easy. I like that. Is x minus x squared. And this is the crucial moment in which I do the second piece of the integral get from 0 to 1 of x minus x squared dx. Antiderivative of this guy is x squared over 2. Antiderivative of this guy is x cubed over 3. Evaluate between 0 and 1. This is 1/2 minus 1/3. And the other variable is 0. Entonces 0 is nothing. The answer is 1/6. Done. End the story. I finish. Okay. This is in this case. So my question is. Entonces, in this specific example, it's better using Cartesian, o sea, rectangular coordinate system XY or polar. What do you think? Polar no good? Or polar good? Or polar complicate more this? What do you think? By curiosity, let's set out work it out well with Cartesian. Okay. Pero you want, Daniel, Gerardo, que I at least set out the polar double integral to see if it's more complicated or it's better. I don't know. Maybe you get the same answer. Well, of course you get the same answer because the mathematics is the exact science. But let's set out, just in case, double integral and polar in the same region, no? First of all, I need to change the integral function. The integral function is y, pero no y. R now is r sine theta. And the Jacobian is r dr d theta, so we have one extra r. This is r squared dr d theta. By modification, the integral function in polar. Okay, now the limit in r, go. I go again to the region. I try to understand. But now the integration is in this direction. So r moving in this direction. From 0 to the r of this circle. But the r of this circle, the equation, remember, was, I don't remember. Well, no, I remember, yeah, I remember. Look here. And polar was, this is x squared plus y squared equal to x. This is r squared. I did before this. 2r cosine theta. So you cancel out this one. R is equal to cosine theta. Okay, this is the r. This distance, okay, by the way, is not constant, it's a variable. Depending the point here, different r is depending of theta in this relationship. So I set up the limit from 0 to 2 cosine theta. And what about theta? Which theta is the angle that is measured from always from here. This is theta equals 0. So, and specifically, our region go from this theta to this theta. So this is the theta 1 and this is theta 2. It's obvious that theta 1 is this angle, que es pi over 4, and theta 2 is pi over 2. So the theta go from pi over 4 and pi over 2. Okay? Entonces you see, wow, I suppose it's a little bit more complicated bipolar because you lost the advantage of the polar, que the limit is a constant. Si the limit is a constant, suppose que this cosine do not exist. Entonces it's okay, because I separate into integral You separate the R part and the theta part, and you integration separately, and multiplication both, and that's it. No, but in this case, no. In this case, we have limited variable, and you need to apply iterate. It's no big deal. It's no big deal. Let me try to do. Let me try. Or Wolfram Alpha directly, or I encourage you. Okay, you put in the calculator or Wolfram Alpha. Gerardo, I suppose you learn how we put the integral in the calculator. Yes or no? In the TI-89. Yes or no? Yes. Okay, super. Very well, very well. Okay, guys, entonces the answer is the same. No problema. And we finish the review package. Fortunately. Okay. How do you feel? Strong? Weak? You need to practice more? Sorry. We finish everything? Done? Yeah. We start new chapter today. Fantastic chapter. Pretty strong, pretty strong. Pretty strong. We never say totally strong, but you know. Okay, so we start the new chapter. In the email I sent to you, we have a PowerPoint presentation. In this PowerPoint presentation, you can see something about the. Okay, one should feel weak with the professor best. No. Okay, thank you, Ricardo. Ricardo is my support always. He put in the ratemyprofessor.com. Dice Calculus 3 is easy. It's not true. You are a liar. Calculus 3 is hard. Okay? See, the student can say que Calculus 3 is easy than Calculus. Okay, Ricardo. Okay, let's go. So the topic now is vector calculus. Vector calculus. Calculus. Okay, entonces we're using this vector calculus in another subject, an engineer, que I suppose que you are doing, like a fluid mechanic. And of course, electromagnetism, electromagnetic field, electromagnetic wave, something, electromagnetic, different university call it different name, electromagnetic wave. Okay, this is typical vector calculus. The most important concept is to understand definition of the vector field. Pay attention, because vector field is the mathematical object that we are using from now to the last day of this subject. Vector field. You perform different operation, no using function. No, function is a history. Now it's vector field, the object that we have in front of us. Let me try to explain the definition of the vector field. Because in Cal 1, remember, I recall always Cal 1, Cal 3, Cal 2, and vector calculus is the new subject. It's inside, in Miami they call it, no? Inside the Cal 3. In Cal 1, we have functions. And we have domain and range. And the domain is one input and one subset of the real number, no? One real number, R, fancy R. One input gets X, and we have one output, and the same is, and the domain and the range, domain in general, is subset of the R. And this is the interesting part in college algebra. Find the domain. Find the domain is the supposition is all real number, and so you find restrictions. This is Cal 1, single variable, one input, one output. However, in Cal 3, we study multivariable functions. Entonces, cal3, because cal2 is the continuation, no? We continue single variable, single variable. But we have two possibilities. You have this possibility, two variable, two input, and three input. So in this case, we have two input, two input. The input is x and y, no? Entonces now our domain is subset of the R2 plane, and the range is one output, a subset of the real number. This is cal3, and cal3 we have three variables. You have to have three input belong to the space, three dimension, and one output, a subset of the R. This is cal3. Now in vector calculus, we are doing different. In vector calculus, we are doing different. We are doing in this direction. We are doing vector field. Wow, what the hell is vector field? Well, we have vector field in 2 dimensions, and we have vector field in 3 dimensions. Therefore, we have 2 input in 2 dimensions, 2 input. Okay, this input is subset of the R2 is x and y, exactly the same of this, look. But we have 2 outputs. This is a new thing. Belong to the R2. Why? I don't understand, Professor. The definition of the vector field is a function, but this function, for example, you have f(x, y), you define like a vector, and this vector have 2 components. The letter gets used frequently, and that part is p. So the function p represents the first component, and the function q represents the second component. So this is equivalent. This is equivalent to say the p x, y I plus q x, y j. It's a vector. It's a bunch of vectors. And so you see after that what is the sketch of the representation. Vector field is a little bit complicated. It's a bunch of vectors. Okay? But no, this is after. So now in 3D, we have 3 input in R3, but we have 3 output. Because in this case, our family of the vector contains 3 components. So in 3D, the vector field x, y, z is equal, we have 3 functions. And normally the letter is the same, p, x, y, z, q, x, y, z, r. I don't know, pqr, x, y, z. So you try to write the vector field using Hamilton notation. This is p, x, y, z, I, plus q, x, y, z, j, plus r, x, y, z, k. Entonces now, si one friend asks you, do you see that you study vector calculus? Yes, I study vector calculus, but I don't understand anything. Well, a vector field is a function, and this function assign any point in the plane, si es 2D, or in the space. Okay, suppose that we have a rectangular coordinate system, x and y, and you have different points, pam, in the first quadrant, in the second quadrant, in the third quadrant, in the fourth quadrant, at any point. And you assign state relationship function, assign one vector. Okay, I don't know, see this vector in this direction. This is a vector field. And likewise, happen in the three dimension, no? In three dimension is more complicated. But don't worry, because in the email I will send to you today with the video, I sent to GeoGebra a script que allow you to visualize any vector field in 2 dimensions or in 3 dimensions. Because it's complicated. Today we are doing something by hand, by curiosity, not to understand. However, no by hand. Any question about definition of the vector field? Okay, one more thing. We have vector field and we have a scalar field. This is not, in my opinion, not super important, because I want to see now in detail one picture and you understand. Because basically it's the same thing we studied in Cal 3. So in Cal 3 we studied surface or solid. Surface or solid. Surface 2 dimension, solid 3 dimension. So suppose that you assign any point in 2D plane flat or in 3D space with the one scalar. Maybe a scalar is a temperature. Maybe a scalar is a pressure. No vector. Si es velocity es vector. Si es force es vector. Pero si es scalar, es a quantity, es scalar, temperature, then it's a scalar field. So, but this is, is a word to define two things or two ideas that because in Cal 3 you define, so you have one output, and this is a scalar field. To understand much better, well, so you have no question, see everything is clear. I don't know if it's clear or no. This is the time to ask me any question. Shayir, Hadi, wow, it's too late. Jocelyn, Annette. Okay, question. Do you understand the idea for the vector field and a scalar field? It's confusing or not? Confusing or clear? It's important. Remember, this is suppose that you start with the arithmetic. Yeah, good. Suppose that we start studying arithmetic. 2 plus 2 equals 4. Entonces, I explain now the number. The number is a quantity que represent Entonces, vector field is the elementary thing que we start to understand vector calculus. Okay? Okay. Let me try now. Here I have something. Let me see. Okay, I sent to you this PowerPoint. I create the copy of this PowerPoint in the board. Do you see or no? Do you see or no? Yes. Okay. Super. Look. The first slider is the idea for the scalar field. Suppose that we have a lamina or something, I don't know if it's metal or no, and you put here in one specific point, que is this point, you put a heat source, and the temperature of this heat source is 250 Fahrenheit degree, no? And the heat propagate throughout the lamina and create different temperature. So basically, the thing we are doing is you assign a scalar field in which any point in the lamina I assign different temperature, but temperature is a scalar, no vector. Therefore, as you can understand this, look in the second slider, you see it is like a surface. So the peak of the surface is the highest temperature, is 250, and the temperature decreasing in both directions, in any direction, in 3D, in 2D, sorry, in 3D. Entonces, this basically is the scalar field que representa temperature. And we have three coordinates, xy, or xy si es 2D or 3D, or depending the time, because sometimes you need to study. Depending the time is more complicated. Depending of time, you study when you study differential equations. O sea, I suppose in Cal 3, in vector calculus, you suppose que time is constant, and you study what's going on in one specific time. So the time is constant, no problema, no variation of the time, super. Now vector field, vector field, no, it's different. Vector field, suppose this, look, vector field, okay, is this. Okay, to understand vector field, we have this map. In this map, you see this arrow represent, for example, the speed of the wind in one specific time. I take a picture, bam. No, you see in the forecast of the weather that this arrow is moving, no? Entonces in this case, more complicated because the time is not considered constant. But in this case, we study in one specific time. I take the picture. This arrow represents the speed of the winds in this country in one specific instant of the time. Okay? And the PowerPoint, you can see, I put here a variable. And this variable, you see that this arrow is moving, but when I make a copy in the board, no, it's static. So basically, is look, this is a vector field. Okay, explain in the other board. We have two possibilities, 2D or 3D. And the function normally we call PQ. P is the component in I, Q is the component in J, and PQR, we addition one extra component in R, que is in the component in K, so on the Z-axis 3D. And everything is function on two variable or three variable. Okay? And so I try to illustrate, wow, what the hell is that? It's a vector field in 2D. Don't worry, be happy. I want to explain how we are doing this sketch. Super easy. And 3D is more complicated. What the hell? Look at that. Pardon for interrupting. En caso que la vida real se usa esto. Yeah. Of course, I explain, I don't know if you are here or not, in fluid mechanics. So you need to study another subject depending on the vector calculus. Fluid mechanics is one, and electromagnetic and weight is another subject. So you need to know that. So this mathematical tool you need to know to understand the professor explained fluid mechanics or electromagnetic and weight. I don't know exactly what's the name in FIU, for example, or University of Florida, is electromagnetic science and weight, something like that. But it's basically the same idea. This is the picture in electromagnetic. Electromagnetic. Only electromagnetic, like that, is the name. Entonces, en electromagnetic, we using vector calculus and using operator, because today we study definition now, blah, blah, blah. But behind this, we have integration, differentiation. Okay, this is just the beginning. Okay, this is one picture, quickly picture. You say, Professor, where I come from this? Well, no. I want to send the script in GeoGebra. Okay. Thank you, Ricardo. Okay. So we have different examples of the vector field. Example 1, 2,1, and this is constant. So the vector field is oriented in the same direction. Example 2 is different. X, 0. So we have component only in X, and we have no component in Y. Okay, and the component in X vary depending the point. At the beginning, when the X is smaller, the vector is short, however increasing. Okay, but okay. I want to do. That is a reason. I have here that grip. In that grid, I want to do the graph of the example 3. Example 3 is a vector function, vector field que es equal x, y. Let's do it. Let's do it by hand. Let's do it by hand. Suppose que I suppose que this is the point 0, 0. 0, 0 is here. It's here. 0, 0. And 0, 0, si x is 0 and y is 0, the vector is 0, 0. And 0, 0 have no magnitude. It's just the point. Pero suppose this point, que es 1, 1. Bueno, si el point es x, y, and y, the vector is the vector 1, 1. And the vector 1, 1 is a vector que is represented by this arrow. Okay, 1, 1. So the magnitude is 1. Actually, well, something like that. All right, let me see. Something like that. No completely, because see, this is 1 and this is 1, this is radical 2. Okay, it's radical like that. It's 1, 1, 1. Si the vector, si the point que I select is 2, 2, the vector is 2, 2. Entonces the vector is a little bit more like that. Do you understand this? It's super easy. Super easy. Suppose que I'm doing exactly the same in the opposite direction. Suppose the point -1, -1. It's like that. Suppose -2, -2. Oh, it's like that. Suppose that point. Okay, that point is -1, +1. Entonces, like that. Entonces, this is like that. Okay, entonces you can see que this vector field. Suppose another point here to understand. This is the point 1, 0, no? 1, 0, 1, 0. So x is 1, y is 0. The vector field look like that. This point look like that. This point look like that. This point look like that. So suppose in 2. 2 is like that. Suppose -2. Suppose +2 and y. This is 1, 2, no? Like that. Approximately this is 2. Oof, like that. Okay, do you see? Okay, this is called totally radial. So the vector field travel radial. Radial means que es suppose que this is the, suppose in electromagnetism is this is the electric charge, positive, and this represents the flux of the line of the electric field. In one particular case of the vector field. And this is, I suppose the charge is positive. So the charge is positive. The line of the flux travel out the charge. Bueno, suppose que now the charge is not positive. The charge is negative. Suppose que this charge is negative. Entonces es exactly the same, pero en opposite direction. O sea, the line travel in opposite direction. How you represent mathematically the vector field? Bueno, entonces negative. When the charge is negative, makes sense, no? Si the charge is negative, the vector field is in opposite direction, y es negative both. Super. Everyone follow me? Okay, super. Okay, Jocelyn dice, I like that. Okay, yes. Okay, Jocelyn. But I have more. Suppose now, can we come back again to the same vector field, que es radial. Okay, the original, when the charge is positive, not negative. Okay, que es x, y. I like this example because it's important to understand the idea for the vector field. Now, suppose que hay modification a little bit. Suppose que I find the magnitude of this vector field. Bueno, the magnitude is square root x squared plus y squared. Yeah, I create new vector field. This is vector field 1 because of the first one that we studied. And suppose now that we create another vector field I want to call F2, vector field 2. Que es, well, is the vector field que is x divided by square root x squared plus y squared, comma, y equal square root x squared plus y squared. So the only thing I did was divided by the magnitude. Entonces, I suppose that this is a unit vector, no? The other vector, the original vector is no unit vector. Remember, when you moving, in this case, too far off the chart, the electric field is increasing. Actually, this is not true. This is completely false idea. Now, in this case, the unit vector. So now, look, I try to represent using the software I talked to you in the example 4. You see that now our vector field is a family of the radial vector, but everything is unit vector. Do you see or no? Everything is unit vector. Wow. Fantastic. Okay. 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 Another example. Look, another example of the unit vector is this. Case, suppose vector field number 3 is minus y comma x. Well, I have no idea. When I put in the GeoGebra application script, I see something like that. Look. However, I try to understand a little bit. Suppose that you are doing to understand a little bit the multiplication, the dot product between this vector field 1 is this. Dot product vector field 3 is this. So we're doing dot product. Remember, dot product is multiplication of the component. No? The first component is minus xy, multiplication this times this, and plus xy. So because 0, wow. Therefore, they are orthogonal. Okay, remember, the other vector field that we study, I remember, okay, this and this are orthogonal. Okay, let me try. Okay, the other vector field that we studied at the beginning is totally radial, remember, no? Now in this case, no. In this case, is orthogonal. Do you see the line are perpendicular to this? Orthogonal. Entonces, another curiosity is que some vector field rotate like that. In this case, rotate counterclockwise. And another no. And another rotate in the clockwise direction. Look here, another vector field. This case different a little bit. It's also perpendicular to the famous radial vector field. And remember, the radial vector field is x comma y. It's the first we studied, and now it's perpendicular. This is, I change a little bit the sign. Look, it's a y comma negative x. When you perform the dot product, it's 0. We prove que es orthogonal also, but in this case, rotate clockwise. Okay. Look like, suppose que this vector represents the wing of the hurricane, and when the one vector field rotate, okay, it's a hurricane, right? Ajá, entonces es importante, we study in detail some parameters o some operators, sorry, que we detecting si the vector field rotate or no rotate. Okay, rotate or no rotate. So we study in detail, not today, maybe, I don't know si today or no. One operator que detecting si es rotate or no rotate. So you see one sign que dice no conservative, conservative, no conservative, but I don't understand what is conservative and non conservative. One of these idea for the conservative somehow is regarding the rotate or no rotate. So for example, in the first one, well, on the first one, no, a ver, let me see. Look at that here. This is the famous radial, que radial no rotate. Entonces, this is conservative. This is no rotate, it's conservative. O sea, when the vector field is irrotatable, not rotatable, it's conservative. Yeah, I want to explain the word conservative. What is that? And when they rotate like that or like that, and then it's no conservative. No conservative. Okay, entonces let me explain more clear the idea for the conservative or no conservative. Conservative what, professor? The energy. Suppose the gravity. Suppose that I need to do the vector field of the gravity. So now let's do it. Gravity. Gravity is very well known for every student. Suppose the point. We are doing a grill to do vector field always, anytime. And you know que gravity is a vector field. Bueno, gravity near the earth. Because gravity in the planet is a little bit different to think I want to do the sketch now, to draw now. So vector field of the gravity is 0, minus j. And j, you know, is 9.8 meters per second squared. So the gravity pointing always down. So the vector field of the gravity look like that. Bang, 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 and the same magnitude, que es 9.8, negative down. It's super easy to understand gravity. Okay, this is disadvantage of the doing by hand vector field. It's easy, however, it's too long process. And this is easy. When it's complicated in all directions, too hard. Suppose now que I travel in the vector field using this path, this trajectory. Closed trajectory, closed. Any closed. In what direction? In any direction. I assume que es in this direction. Si it's in opposite direction, is same result in this case. I need to compute the work done by the vector field. Work done by the vector field. Let me explain the idea for the work. Let me recall. I suppose that everyone took physics, no? Or are taking physics in this moment, no? And you know the work in elementary idea. I want to complicate a little bit. Not today, no? Or another day. It's a multiplication of the force times Doppler displacement. Or displacement is no S, is R. It's a vector. Or in physics, simplify the thing, magnitude of the force, multiplication magnitude displacement, case distance, cosine theta. So basically the physics say multiplication force, multiplication distance or displacement not distance, sorry, distance, cosine theta. Entonces when you travel in the opposite direction, okay, for example, I divide this trajectory in 4 segments from 1 to 2. Es obvio que the work done by the vector field is negative. The work is negative because we are moving in opposite direction to the vector field. Therefore, the angle in between the force, okay, the force is the red one. No, actually it's the gravity, no? But if you multiply by the mass, it's a force. The work is negative. And the trajectory between 2 and 3, the vector displacement have that direction, the vector force have this direction. Es obvio que es orthogonal, perpendicular, and the work is 0. Same situation happen in between 4 and 1. Work is 0 when it's perpendicular. However, in between 3 and 4, we have in the same direction, so the displacement and the force is in the same direction, therefore the work is positive. And by the way, this work and this work is exactly the same work for the opposite direction. So the work done in the closer trajectory is 0. And this situation happens in the conservative vector field. And the non-conservative vector field, no. That is the reason it's conservative, because it's conservation of the potential energy. Okay, in this case, you know, you compute in physics the potential gravitatory energy, like NGH, and you don't know exactly what you compute. You say, you accept the professor, no, this is the potential energy. Okay, but what is the connection with the mathematics? You see here the connection for the mathematics. Okay, entonces associate. Okay, let me summarize. Stop. We have two kinds of the vector field, conservative and non-conservative. And what is the definition? Conservative is the work done in one closed trajectory is 0. O sea, for example, the energy que you spend in your muscle, for example, to move over the object inside the vector field, because in this case the trajectory from 1 to 2, for example, you are doing work. However, the gravity doing negative work. So you are doing positive using the muscle. Okay. This work I spend using my muscle in between 3 and 4 is returned to me, like a vector field help me to move in this direction. Wow, amazing. When the vector field is no conservative, no. Okay, but we have more. So you have said to me, okay, in one closed trajectory, the word 0 is because the word is totally independent of the path. Path independent. What means that? Well, suppose you have 2 points. This point and this point. Yeah, I travel for this direction. I suppose, okay, in this case, the word is positive, no? Because it's similar to this. Not exactly. I promise I want to teach you how you compute the word in any trajectory using integral. However, suppose I have another path like that. Well, what is the word in this case? What is the word? It's positive in the green part. And this is the word. Okay, always is positive in the red part, but it's the same. Why? It's the same. Because you consider that this is a closet, okay? Suppose the closet, to suppose the closing, I inverted this arrow in this direction. Entonces, the work done in the green part is positive. Now the work done in the red part is negative, but the work done in the entire closed curve is 0. Therefore, conclusion, the work done and the green part is equal the work done and the red part. Do you see or no? Work done and the green part is equal the work done and the red part. Okay, entonces this is called path independent. Independent. And this always happens in the conservative vector field. And the gravity is a good example. That is the reason that to find the work done, you don't using that formula. No, you using that formula, que es the potential. So you find potential energy, and basically, I want to study Mathematica in general. Not today, because the time is over almost. How you find potential function, que define potential energy. Entonces to find the work done in 2 points, si you proved before, que it's a little bit complicated, que the vector field is conservative. Entonces now I know que this vector field is totally path independent. Entonces you need to find the potential function and the point 1 and the potential function and the point 2, and you subtracting, and you find the work done, because it's totally path independent. O sea, it doesn't matter que you travel for the green, que you travel for the red, or you travel for any trajectory. This one, this one, this one. Well. See, you prove that the vector field is not conservative, because it's rotation, and then to say you are in big trouble, because the only possibility to compute the work is using the formula of the work. And the formula of the work is a little bit complicated in the vector field, because the vector field depends on the position. So you need to use it not like that, you need to use integral. Okay, this is the roughly introduction. Super. We continue working with the vector field. So the most important I want to present to you is what is the vector field? And we have 2 kinds of vector field: the vector field conservative and the vector field non-conservative. And non-conservative is synonymous to say rotational. So we have rotation of the vector field. You see some moving. And how you see with your eyes? No. We have operation que allow me to understand que is rotation. Rotate. Okay, look, let me show you, for example, suppose, let me spend the 2 minutes that we have. Look. I want to see something funny. This is very, very funny. Let me see. Sorry, I lost something. No, here, over there. Let me share this screen. I want to send to you this. Let me see. Here, over there. There you go. Do you see this screen? Okay, look at that. This is a vector field. This is the script in GeoGebra. Not create for me, guys, but this is very, very complicated. It's a professional. It's a professional. Okay, now suppose. This is typical XY. Look at you put a component of the vector field. This is a 2-dimension, of course. And you see it's totally radial. And to say now, in the last class we studied 2 operators. One operator is called curve. Another operator is called divergence. And this give me information, some rotation or no rotation. I want to explain the interpretation, divergence, and curve. But I want to illustrate a little bit. Look. Suppose I change a little bit this. I put a negative here. Bam. No. Sorry. Suppose this is negative y here, negative y, sorry, I always make a mistake. Negative y, and here x. Okay, was the case that we studied. Negative y and x. Okay, look at that, look at that, look at that, look at that, look at that. This is totally rotated vector field. And you see in this animation, look. Okay, so we have one operator I want to study in the last class. Can we evaluate in any point, look, in any point, and give me if the vector field rotate or not. Entonces, this number 2, I want to explain the interpretation of this. You can rotate, in this case is rotate counterclockwise. Sometimes no, sometimes rotate clockwise. And this vector field obviously is not conservative. No, not conservative. Okay? Well, okay, this is motivation. Okay, now you have a lot of work. Remember, Monday we